Geometry, Chapter 8, Lesson 1, and we've been working with the Pythagorean theorem. And the Pythagorean theorem says that if you have a right triangle, then the sum of the square of the legs will equal the hypotenuse squared. We then use the converse of that, and by substituting three values into a squared plus b squared equals c squared, and if that ended up giving us a true statement, we were able to tell that this was indeed a right triangle. So the converse would say that if the hypotenuse squared is equal to the sum of the square of the two sides, then we know it's a right triangle. Well, what happens if we substitute those values in and it doesn't end up being equal? Does that tell us anything about the triangle? And actually, yes, it can tell us whether the triangle is acute or obtuse. The three values, if they are not a right triangle, we can use the same Pythagorean theorem and then, based upon the statement, determine whether the triangle or the sides represent a triangle that's acute or obtuse. And here's how we do it. If you take the longer of three, or the larger of three values, and substitute them into a squared plus b squared equals c squared, the larger of the three values going into c squared. If that c squared values ends up being larger than the sum of the other two squared, then we know that it's not a right triangle, but we can tell then that that is an obtuse triangle. So if that value, if the hypotenuse squared is larger, then those three values represent an obtuse triangle. If that hypotenuse squared is smaller than the sum of the square of the sides, then we know that the triangle is not right because it's not equal, and we actually know that the triangle then is an acute triangle. So even though the Pythagorean theorem tells us that if it's a right triangle, then the sum of the square of the legs is equal to the hypotenuse square, even if that doesn't end up being the case, we're still able to tell something about the triangle based upon the values that we get for the Pythagorean theorem. Okay, so for the remainder of this lesson, or for the rest of the problems in this lesson, what you're going to do is you're going to be given three values, and you're going to be asked, is it a right triangle, or is it obtuse, or is it acute? And again, the writing out of the explanation is going to be the toughest part, because substituting in the values into the expression is easy, and then doing the arithmetic is most likely easy. And so then all we have to do is explain our answer. And again, the wording is the most important thing. Okay, so if it's obtuse, the hypotenuse squared is larger than the sum of the square of the two sides. So again, it's the sum of the square of the two sides is going to be the most important phrase when you do this. Okay, so let me do one example or two so you kind of get to see what you're going to be doing. So let's take the values 15, 11, and 12, and the question is, what kind of triangle does this represent? Now, are these sides of a right triangle, an obtuse triangle, or an acute triangle? And again, we're going to use the Pythagorean theorem to help us do that. So we have a squared plus b squared is equal to c squared. Now it's very important to remember that the larger value goes in for c. So I don't want to put 15 here. I need 15 over here because that's the larger of the three values. So I'm going to put 11 squared over here, plus 12 squared, and then 15 squared. 11 squared is 121. 12 squared is 144, and 15 squared is 225. So if I add these together, I'm going to get 265, and now that's greater than the 225. So because the hypotenuse squared is less than the sum of the two sides squared, this will be an acute triangle. So again, your answer should look like this. This is an acute triangle because the hypotenuse squared is less than the sum of the two legs. No, see, I almost wrote that wrong. See, inside, I got to be careful. The sum of the square of the two legs. Okay, so again, be careful that you write what it is you mean. and that you express that correctly. So this is an acute triangle because the hypotenuse squared is less than the sum of the square of the two legs. Okay, so we can use the Pythagorean theorem to tell us what kind of triangle we're looking at, even though the sides may not represent a right triangle.